All right, before the break, we were kind of looking at the syntax for arrays and a couple of random that we will see periodically, come back to periodically and just build up that other part of the, like the build instructions and package David handles for us. We usually have a computer handle that because that's really, really boring. Sometimes called task-oriented programming. That's like a location and objective. So it's like go to this directory and do this step, and navigate to this directory and do a step here. Moving around the terminal, CD do one thing, CD to a different directory do one thing. Really, really boring code to write. Really easy. Doesn't take a lot of thought. That's what it's generally automated. That's the sort of stuff that's handled in the package management. So I was just going to work those pieces in small little bits like that. Like when I look at the clock and it's 5 minutes before I was planning on taking a break, then we'll work in the pieces of that throughout the semester instead of sitting down and spending a whole night on the really boring parts of life. So back to our collections of things. I like to use this analogy. So let's come to school. This stuff for the class here. I can just stack all this stuff up and carry it around. No problem, right? It gets around. I drop a couple things, I'd stop and pick them up. And you can carry that stack, but that's not the best way to do it. Right? This is kind of what we have with variables, whereas a collection like arrays and lists would be like a backpack. You put all the stuff in here. Put all the stuff in there, then it's a lot easier to carry.
It's stored in a distinct place.
A distinct place, and then when we need it, much like that loop that we put in the code there, we just loop through all the elements in the backpack, right? Maybe we need my little digital pen to annotate stuff on the screen. Then start looping through there. There's something in the backpack. Is that digital pen? Simple condition, no. Is that the digital pen? Nope, that's the folder. And eventually get down to the little felt case here. That's the digital pen. Like that's what we need. So sort of that same concept. We take a lot of that for granted, but that's what we do whenever we put all our stuff in a backpack or a suitcase or something to carry it. And working in collections is the same way. So when we write our code, we get those advantages of carrying a backpack instead of a stack of books. Arrays are nice, they're faster. That's the big thing. All of that fixed qualities, everything. We reserve our resources in advance. How much of the RAM do we need? How many registers do we need? How much of the bus line are we going to occupy moving things back? How many cores in the CPU are we going to need to move this stuff? We reserve all those resources in advance so the computer never has to waste time figuring them out. We get a lot of speed out of it. Oh, there's Gabriel. But that fixed size can be a bit inconvenient. That example I kept going to earlier, this one here on the board, I said, okay, we have an array holding 4 bytes. But if at some point later we realize we have a 5th byte we need to hold, the only thing we can do is make a new array that's a little bit bigger, copy everything over and store that. And then what happens if a few lines of code later we realize we actually needed a 6th thing? Or if it's dynamic, we don't know when we write the code how much we're going to need. We could need 4, we could need 400. We don't know what the user's going to want. Arrays kind of hit a big problem there if it's going to be completely dependent on the user. So another very common data, I want to use that word. Yeah, data structure. These are data structures. We're talking about those at length later. I'm going to make the definition up there. Hopefully everybody's heard that word before. The short version of it is, I know you've heard of databases or databases, whichever way you want to pronounce it. Database is in storage. A data structure is in RAM. How do we get our data into RAM? So kind of like this picture here for arrays. How do we bring our data, in this case, the one drawn on the board, 4 bytes, how do we get those 4 bytes into RAM so that we can find them quickly and efficiently
get them out when we need them. Oh, another problem is this fixed size. What happens if we delete index number 2 here? Everything was fixed in place. So then we just have this empty spot, big empty spot. So another very common one is a list. I'll just draw the picture. I ran out of room to write the definition. A list is a collection of data. It can be mixed type, except that we're in the dynamic, or we're in the strictly type language. So we usually don't mix the types even in our list. I'll show you the shortcut for that probably on Thursday if we want to mix the types of data. But a list basically just has a pointer to the next element. So we have our start point, so maybe it starts here. I'll say a list of bytes. I'm not gonna write that. You'll see it has to be different. We'll see that in the Java syntax in a minute. So we have a list of bytes again. So we put our first 8 bits here. And then we just add a pointer. This is one we will definitely code up when we get to our data structures. That's not something fancy. That's just a variable that points to that's just a variable name that holds the next one. Usually we use the word next for it. So in that object we add a data field that says next, and that just points at whatever one's next. From this picture, it looks like there's some space down here to put another byte. We add that pointer at the end and it points up at something else. And we can scatter things all over RAM, put them in different places. That emptying out thing, maybe if we want to delete this one, all we really have to do is stop pointing at it. We can delete that pointer and just move the pointer there. And now there's no longer any way to access that. So garbage collection will notice that there's no way to access it and delete it pretty quickly. I've got 3 things in the picture there. So if we set it up with 3 things and then discover later we needed a 4th thing, all we need to do is point at something else. And eventually we get that point, we hit a pointer that doesn't go to anything, a null pointer. You're probably familiar with that because of null pointer exceptions when we accidentally point at nothing. But in this case, we're doing it on purpose. That's how we tell we're at the end. So it's not an error in this case. That's just how we identify the end. And we can dynamically extend those, remove things from them. By definition, they don't have to be similar typed like arrays do. We can mix and match types, but we are in a strictly typed language, so usually we don't in Java. I'll show you how to get around that when we get to, I'll show you a shortcut around that on Thursday. But for tonight, we make a list. I'm going to close out of this Maven project and keep those separately. Save that. And yeah, like I said, that really boring code, the stuff that is super easily automated because it doesn't require any thought. It's just a matter of typing up the stuff, and it's usually a lot to type. Really boring to do, doesn't require any thought. That's the sort of stuff we want to have our IDE do. So it'd be like tonight when we looked at dependencies, when we're doing stuff and I look at the clock and there's like 5 minutes left, an extra 5 minutes before the planned break time or anything. I'll add little bits and pieces in there instead of trying to sit down and spend like a whole hour or something on the really, really boring this semester. We'll do it in little segments. Let's do a new project. I'm going to go back to Ant. Most of our stuff in class, I'm just going to do with Ant. Let's do another. We just did at least 2 things in the console right in order, right? Let's do one in the web page this time, change it up. So I'm going to go to Java Ant and go with Java Web and create a new web application. We saw this in preview mode the first night. Buttons are in the way. We're going to move Zoom buttons. All right, Um, web application one, that sounds like a good name for it. I'm gonna hit next. And if you haven't done this yet, this is from when we did it the first time. It remembers that I did install an Apache server. Um, to add, go look for the server. So add, if you follow all the instructions for those setups and install Jamp, there's a Tomcat server on there. So you would just choose Tomcat or Tom EE. Click that, hit next. And where's it at? You'll just browse to where it's at. It should be on the C drive somewhere. If you did the default installation, it should be on C drive rather than Jamp. If you're on a Mac, it's in your applications folder. And it is, the folder is called Jamp, and then when you go inside of that, you'll see Jamp.application, and when you go inside of that, then you'll get to where you eventually get down to the Tomcat server. But just go to where that's installed, and in particular, what you want to do, go in that Jamp folder, and then the Tomcat folder, and when you can see the folder called bin, you don't want to go into bin, but when you're in the directory that's the parent of bin, because you want all these other things too. That's what I always do. Just go so you can see the parent of bin. I'm going to cancel out of this because I already did that. Then create a username and password. And this is the username and passwords NetBeans will use to access the server. And it will create it for it. Knows how to go in and configure that automatically. What you have to do is put your username and password in this. Make sure you click the create if it does not exist. Fill that out. I'm going to go ahead and cancel out of this. On the next screen, there's several options to choose from. One of them is Spring MVC. We're going to use Spring MVC through Spring Boot this semester. There's some other options for frameworks, and at this point, leave all of them unchecked. We'll get to frameworks soon. So the screen after this, leave all the boxes unchecked, and then hit OK, and then you'll get back to this page, and NetBeans knows there's an Apache Tomcat server and has a username it can use. Oh wait, this is the box. So I guess this is the page I was thinking about. These are frameworks we can choose between, and we'll get to frameworks pretty soon. So we don't need any just yet. Just gonna go ahead and hit finish with all those unchecked. I thought those were before we came back to that. And you'll notice it created an HTML page, which I don't actually want the HTML page because I want to do some Java code. Discard the changes. Stuff in a different order. There's this folder called Web Pages. And in that is this meta INF as far as meta information or web information or background data, depending on how we use it. And then that web page. But I want a JSP page so I can write some code with it. So I'm going to click up here and hit the new file button. There's lots of new file buttons. Right click and the new file up here. You can see the keyboard shortcut, hit Control N. Lots of different ways. The big thing is make sure the right thing is highlighted. So generally you want to put it where it's going to go. Right now it's got the whole project. So if I just created a new file, it might not know which folder to put that in. I can see the current index is in this web pages folder. So to replace that with index.jsp, I want to put it in the same folder. So I'm going to highlight that and then hit the new button. So just remember to always double check before you hit the new button. Make sure you're creating a new file in the correct location. New JSP pages, that's Java server pages. We saw those, we run some Java code on the server, and then when it transmits to the client only sees the result of it. So we embed Java, mix Java and HTML. I'm going to call it index. If you happen to click in the wrong spot, here's where you would change the location of where it needs to go. And make sure it's a standard JSP file. Which, if I get out of the code, so let's see, there's should look like HTML. Has everybody seen HTML before? I hope there's a yes from everybody in Zoom call. I've seen HTML.
Yeah, I remember MySpace.
Oh, sorry, what was that, Gabrielle?
I said, yeah, I remember MySpace.
Okay. Yes, it's very useful, especially for CSS. That's the reason stuff is done this way anymore. We can make things look really, really, really nice. For example, tonight's not going to look nice, but when we start adding CSS, we can make it look really nice. And then we can fix it so that HTML, this will run on any type of device. So we can make our GUI with this. So mostly what we want is the form elements, which in NetBeans, I'll just point at this. If you come over to Window and Palette, which is probably under IDE Tools. Yeah, so under IDE Tools, this palette, here's the drag and drop HTML stuff. So like drag in a form. Okay, yeah. So we drag over a form element, and then inside of that, we could drag over a text input checkbox. So there's that drag and drop stuff. You don't necessarily want to type every single one. The predictive text does know HTML tags. I'll get rid of this. So if I like start typing section, there's a section tag, and you can see there the predictive text does know the HTML. So what can we do here? We need a list. Need a place for the Java code. So angle bracket %, and then we come down a couple lines and put % angle bracket. And our Java code goes inside of that tag. Kind of looks like a tag because we have angle brackets, but then we add in the %. And inside of it, we can add Java code, and some line breaks and indenting so it doesn't look like an awful mess. So if we want a list of things, I'll write this. So list, and this is slightly different. What's going on in here would work exactly the same if we put it in a main method. I was just doing it in a web page because we have another web page anymore. Whether it's a main method or the web page, we run the same Java code on it. There's a few extra things in the web page, but we won't see those for a minute yet. So we need a list of things, but it's strictly typed. And we need to say what type of data our list is in. And part of the reason I want to do this in the web page is because it'll fit nicely here. So let's do a list of ints again. However, ints are primitive data, and that becomes a problem here. We also have what's called wrapper classes. I believe this was in chapter 1 of the book, where we spell integer out with a capital I. That's the object version of integer. So instead of the primitive data, like int, it's an object. It has extra, it already has a bunch of methods built into it. You've probably used some of them by now if you've done the homework. Anybody have to use that like integer.nextInt, pull stuff from the scanner in the homework? Double.nextDouble, where you have that class with the capital letters. So that's the object-oriented version of an integer. Notice it went inside of angle brackets. So saying I have a list of integers, and notice how the type of data in angle brackets there, that looks an awful lot like a tag here, right? That's not a coincidence. That this is what's called, when we write our code, it's generics. We'll get to generics very, very soon. Next week, I think. When they created this list and set everything up, they had no idea what we were going to put in here. Could be integers, could be strings. It could be a data type or a new class that we don't create until later this evening. There's no way they could have built that 25 years ago. So what they did is they put in a placeholder, and that's what those angle brackets are. So then when we know what goes in there, then we put a specific type of data to fill that placeholder. It's called generics, and that's exactly what's going on with the tags and markup languages. It's not a coincidence that in our C family of languages, we use this to identify types, and in markup languages, we use this because the markup language does actually feed into This one, this HTML does actually feed into C++ code before it displays on our computer. So it kind of relates to that. Angle brackets with the type of data. I'll give it a name, my ints. That sounds like a good name. Slight problem here. Well, for one, list isn't in there, so I have to import that. I'm gonna hit Control-Shift-I. I think. And okay, the auto import isn't working in JSP pages. I haven't really dealt with that before. But if we look at the message, cannot find it. It knows what to import. I don't know why the keyboard shortcut's not working on mine. Usually Control-Shift-I is automatically imported out of it. Clicking on the light bulb also says what'll fix it. Add import for java.util.list. So we brought that in. Java.util.list. And I'm going to pause there. If you look at that line for a second, we saw some imports the other day, didn't we? In regular Java class. Let me make another Java. Make a regular Java class. New. Put it source packages, default packages over here. New Java class. So over here we would say, this kind of way. We would say import java.util.list. So see how we have the same thing here. Whoops. Kind of the same thing as the attribute in one of those tags with percent sign. So that's how we integrate that into the HTML. So okay, if you stare at it for a second, do you see how that's sort of the regular import combined with the JSPE tags? And just remember at page, there's other ones, but for pretty much anything we do this semester, we're only going to import it for the one page row. We're not going to worry about other pages because that starts to get complicated and confusing and we lose track of it. So I would recommend never do that, no matter how many pages there are. It's a lot easier to keep track of import page by page. It gets very confusing if we use something other than page. So at this page, import that thing. And then we want to set that equal to a new list, which I'm going to do this. So it'll throw an error message. Should get an error message here. Yeah. So list is abstract and cannot be instantiated. That's actually incorrect. List is an interface. I don't know why it's telling me it's abstract. We will get to abstract classes and interfaces next week. A short version of it is like a USB plug. Like everybody has seen a USB plug, universal serial plug, or a universal serial interface. I'm pointing to the HDMI one. A universal serial, it's an interface. There's agreement between different things that these shapes will plug in together. Like that's how I know these KVM switches are going to work on anybody's laptop. And when you use the extra monitors here in the computer lab. Because you all have USB ports and they interface at that point. We have a software version of that. We will get you next week. So list is actually an interface. We can't make this, so we need two common ones. The one I drew on the board is a linked list. Yeah, Control-Shift-I maybe it just doesn't work in the JSP pages. I've never tried it. But if we click on the library, it knows what to import. So you can just click on that, or you can type that up yourself if you want to. I would recommend having the computer do it because making typos is a human trait, not a machine trait. Sorry, I was trying really hard not to cough there for a second. I'm gonna grab one of these cough drops in case I suddenly have a coffee fit in a moment. So typos is a human trait, not a computer trait. So I would recommend letting the IDE do that. But linked list is concrete. List is abstract. We have lots of types of lists we can use. I know you're gonna be leaving in a moment. The other most common one is array list. We will, it's just like the picture here, only those pointers point arrays. So instead of a single elements pointing at the next one, we link together a bunch of arrays. Since you're gonna be leaving in a moment. For this year, I'll review that when we get there. This one does follow Java conventions. We have all methods. When you read through the chapter, I wanted to go ahead and include this. These are going to be more like what you're used to, dynamically sized. We can add things, remove things. It's going to behave a lot more like what you're used to. It's not, everything's built into methods. It's nice and consistent, but it's like chapter 19 in the book. So the reading assignment this week goes from like chapter 3 up to chapter 19. So there's some other things that the book's going to take for granted, because the author expected people to read all the way through, expected to read a whole lot more chapters before you got to 19. So if you get really confused, we will be to that stuff soon and fill in those details, as long as the general idea of what the linked list and my array list is. We can add some stuff. So like my ints, let's add some things. The method is .add, and notice we have a whole bunch of them. .add integer, add int index, an integer. So we could add it at any spot in our list. Could add it at index number 3, index number 300. We can pick and choose what index to put it in, and everything will adjust. Because unlike the array where everything was fixed, we just have pointers. So we just need to move those pointers around to add that stuff into a list. Let's add an integer, maybe a 5. My ints add 7. My ints add 3. Oh, and then this part's nice. If we go print it out, unlike the original array, we can actually print these things out at once. There's a toString method built in. If I run that, it should open the. Oh wait, I just put print to the console. I don't know why I did that. I'm gonna go ahead and open this page, but I didn't actually print it to the page yet. That was silly of me. We don't need to print to a console. That's the whole point of this. So now I'll come down somewhere else in the body, like maybe down here in a paragraph, and say the list is holding, and then add in one of those tags, angle bracket %, my int, right now. And we can just print it out right in our paragraph. So we get a little tag like that. Does it not like that? Oh, oops, sorry. An equal sign. If we just want to put a variable, right? We already have stuff stored in this variable holding a linked list of integers. If we want a variable, angle bracket %, then equal sign, or whatever that is. So now if I stop that and rerun it, always make sure you do that. Right. Sorry, I was going to point at something and then everything closed on me. Let me come back out of this and run that again. So it just automatically opens it because I didn't look at what the address was. Okay, there. Localhost port 8080 web application, and it's showing this to-do list, which is very different than what we have. And that's because there's both index.html and index.jsp. So the server is not going to know which server, just knows to open something called index. But we have two things called index, so it doesn't know which one to open. To an extent, HTML takes preference over JSP. So make sure you delete that HTML page. And then when we run it, we get the result for the JSP page instead of the HTML. Notice how I just print it out immediately. If we have a linked list, array list do the same thing. We can just print that. Same thing if we do that line that I put in there by accident, the system.out.print line, it just shows that in the console. HTML is just to make it look nice in here. Everybody said they remembered that. We could add some CSS, right? Style equals color blue. Make it look a little bit better. Not going to spend a lot of time on that right now, but we have control over it, and it doesn't have to open in a browser. We'll be doing stuff with browser mostly throughout the semester. I put the instructions for the Electron framework in the modulate submission on your final project, because that does require at least 5 languages, and this is a language specific course. So it's kind of hard to justify covering 5 languages to make our web applications look like desktop applications. But it is boilerplate code. It's always exactly the same, and it's like a 10-minute video to go through the steps. So I did put the steps in the final project submission, so that if you want to see how to do the Electron framework. We can remove stuff. So now that that's printed, I could do some more code. Percent. Oops. Be careful with the predictive text. Runables, that thing I accidentally just typed in there, is for multi-threading. So we won't be to multi-threading till week 7. Then I could go back in here to Java code and like remove something. Notice the options. We can either remove an object or remove an index. So if we have a list of integers like we do right now, removing an index can be a bit of a problem. I put 2, 3. Oh no, I don't have enough. I have 3 things, but if we have one more thing in there, there would be the object 3 and the index 3. So it becomes ambiguous on what to remove. I believe the object gets preference, but if I say remove 5 and then print this line out again, copy that, paste it in here, maybe change that to a different color. Oh. Line 27. I'm not sure what the error is. You'll see we get error messages from the server. They just show up over here. Oh, it looks like index took preference. So it was an object number 3. So maybe we should try to remove index number 1. See if it likes that better. There we go. So we removed the second element. So if you have an array of integers, watch out for that. If it's strings, it's a little bit better. Strings or anything that couldn't be ambiguous with an integer, you have, or with an index, you have the option. Okay.
I'm gonna watch the remaining of the.
Yeah, so the video should be up. We're probably only about 15 minutes from the end.
Thank you.
See you Thursday.
Yeah.
Oh, speaking of videos, did you find the videos the other day, Gabrielle? Is she still there?
I am still here, and I did find them. I only got halfway through our Thursday class, and then I'm gonna finish our last Thursday class after this class. My brain is absolutely mashed potatoes.
Yes, that happens sometimes in busy semesters. And then yeah, everything should be available in that spot on Ivy Learn. within a few minutes of the class ending.
Awesome. Thank you.
Oh, I thank you. Did you say thank you?
Yeah, sir.
Okay. Sorry, I started talking too soon. I should have waited till you finished. Okay, so linked lists are going to be one of our most common, and we have lots of different types. Put in strings, bytes, booleans. It does have to be the object. We call them wrapper classes, as in like gift wrapping with a W. So it wraps the integer and brings in a bunch of methods that we can work already built to work with integers. I believe that showed up on week 1 homework, like at least when you're using a scanner and you do integer.next double, or not integer.next int, or double.next double. We need those methods sometimes. So make sure you use those if it's primitive type. But by Thursday we're getting into object-oriented stuff. So we'll be starting to move away from our primitive types then. Also, notice this assignment right here. Maybe it'll be clear. So we also have an array list, and I'm just going to type that one explicitly. Let's put strings in there this time. An array list of strings. I'll call it my strings equals new array list. And then add the import. So have to import that, but this is kind of what we were seeing last week, right? We have a type of data. The next one's going to be an array list, which from this picture on the board where we have like this element, we had a pointer on it to point to the next one. Then this element adds a pointer to point to the next one. It's what should seem the obvious extension to the name, where instead of an element that we had a pointer onto, we put an array. So we make an array. When we say we have a new one, it can hold 16 elements. When it fills up to 15%, so when we get to 8 elements, the thing I said we had to do, right? If we need more, the only option is to make a new bigger one. Once it fills up to 50%, then it doubles in size. Wait, is it double in size? Yeah. Array list, it'll get bigger. So it'll go from 16 to, is it array list or vector? Yes, array list goes from 16 to 32. Some of them, they grow differently. Array list, we start with 16, and when we get halfway filled, so when we get to 8, it'll hold 8, but as soon as we try to add a 9th thing, it does that, delete the array we have and make a new bigger array so we can copy stuff over. So that stuff is just sort of automated in the background. So it's a combination of arrays and lists. But the syntax here, we have an array list, give it a name, and that's going to be a new array list. And notice we have the angle brackets on both sides. On the right-hand side, we only have to put it in there if it's not obvious what it is. Right on the right-hand side, we said when we filled in the generic placeholder, we said we have strings. So we're going to put strings here so we don't need to worry about anything on the right-hand side. Same thing up here. We said we had integers on the left-hand side, so over on the right, we don't have to bother writing the integer twice because it could change. But it could change because of polymorphism. This one looks a little bit different though, right? On the left, it says we have a list. And on the right, it says we have a linked list. So I can do the same thing down here. I can take out the array list and just say we have a list, because an array list is a type of list. A linked list is a type of list. And that's getting into what we're going to cover Thursday with polymorphism, one of our core concepts from object-oriented programming. A big word for a really simple concept. That means using it for something other than its intended purpose. In this case, instead of saying a linked list, blah, 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 equals a new linked list, we just said a list. Because a linked list is a type of list, we could have turned that around. We couldn't say we have a linked list on the left and then say a new list on the right. Because a linked list is a type of list, but a list is not a type of linked list. A list is a parent of linked list. But that's polymorphism. Any type of list will work. Up here on line 16, we have a linked list. That's a type of list, so it's polymorphic to it. A really big word, but it just means that using one tool in more than one fashion. Or down here, it's a list, and in particular, we're going to use an array list. So we're using both of those for the purposes of a list, instead of the explicit purposes of a linked list or explicit purposes of an array list. We're just going to mix and match it. Using one tool for something other than its intended design. Hammer's a great example. That's my favorite example on it. Right? You're going to find a hammer on every construction site. It's a nice heavy object, which means that's going to work great for holding blueprints down on a windy day. But would we ever say that the purpose of a hammer is to hold blueprints down on a windy day? It works for it. It's polymorphic to it. That's a use we can pull from that tool, but it's definitely not the intention of that tool. So I wanted to use this to try and subtly introduce polymorphism. Notice how the types on the left and right hand side don't line up explicitly. That's polymorphism. We will talk about that more on Thursday. Just want to talk about it a little bit. Then we have similar things. So we can say like my strings.add, and this time we're adding a string. So add hello, my strings.add world. Strings.add. Let's use one of those other ones on the predictive text. So on the predictive text, my strings.add. We could also add in an integer and then the element. So we could add at index number 1, I don't know, silly. That worked. So notice we're jumping out of the order. Like up here, we just kept saying add and it just added it at the end of the list. But if we add and then put another index, we can put it in wherever we want. I guess I'll print that out somewhere. Come down here, MP, paragraph, the strings, and then we'll put in that special tag, percent equals the variable right now in that variable tag. Anything seem confusing, odd about that? No questions or anything? It should be straightforward. Basically, this is more like the list you're used to using for Python. They're dynamic. We can add things, we can take them away, and we don't have to go in and worry about what's going on in RAM. We just do it, and then what's happening in the RAM is fully automated in the background. And if we need that stuff on the list, we have a way to pull it. We have a way to turn this into an array at the end if we need to get back to that faster version for some reason. We'll see that soon. I don't want to overwhelm you. I just mostly wanted to look at the add and remove stuff and then glance at a picture. Yeah, that one should be fairly straightforward. It's more like what you're used to. Kind of previewing generic types here when we get to generics very, very soon. On Thursday, we're going to talk about methods, and then we'll get into our first look at object-oriented stuff to go quickly. So generic types, and then a bit of the polymorphism, because on the left, we say we have a list, and then on the right, we just use one of many types of lists that we have to fill that. Big word for a simple concept. Let me jump over to our one real quick. Well, there's two places, because during class here, your go-to is, you're probably gonna look in the textbook for reference stuff, right? When you're reading things. So we go over to our class. And on the A plus bookshelf, make sure everybody can read the picture, the diagrams here. Probably should have looked at what chapter it is. I think it's chapter 19. Oh, 19 is generics. No, 20 and list. We just need the part about list, but 20.5 has the stuff about a list and linked list. So actually, it might just be this reading assignment this week, just those two, this section. Talks about the collection interface. We won't talk about what an interface is till next week, but you'll see what the diagram looks like. So, whatever it is in the UML diagram, we are inheriting from something that has an add, all, get, index of. You see all those methods in there? Does everybody know how to read a UML diagram? So they use that in the textbook. Some examples. So also for list iterators, we walk through it. Has previous, has next. So if we're walking through a linked list, we can check and see if check the next index, check the previous stuff, set things, and you can, the book's going to have a lot of reference put in UML diagram format. And we will get to what an interface is soon. For now, we just maybe look at the methods, but add and remove are the ones we're going to use most often. I wanted to introduce those soon. We will have more to say about the linked list and array list as the semester progresses. Your homework assignment, if you haven't looked at it, you'll do basically the same thing. I probably should have left the book open. But programming assignment from module 2, you'll do exercise 7.1 and 8.29 and use the arrays, those fixed size ones, the stuff we went over before the break. Do it that way, and then you'll come back and redo the same exercises using an array list and a linked list. So you do the same exercise twice, compare and contrast how to do each one. That'll get you some practice with them. But yeah, the important thing is to note that it is duplicated. Arrays, lists, and we still need to talk about methods. We're talking about that on Thursday, but that's going to go really quickly because everybody's seen methods before, right? We just need to see the syntax of methods in Java. And if you have tried stuff so far, you may have encountered an error message that says static, non-static context. We'll see how to deal with that very quickly. Our book really likes to do stuff in static, so he keeps doing it with it. And we look at the reference material in the book. Remember the official reference material? We have a spot for official reference material. So if we looked up like array list in Java, so you have the book, but I would highly recommend coming over here and checking the actual documentation. Java has wonderful, wonderful documentation. Websites are generated from comments, java.comments in our code, which I think we can look at real quick tonight. And if you look through here, you'll see a big, very thorough discussion because array list is something that shows up in pretty much every Java class everywhere. So people see it from the beginning. So the description of it is very, very detailed. As you get to more advanced functionality, the description gets clearly isn't for people being introduced to programming for the first time, but a really great description. And most of it's down here. So our constructors, we can either make a new array list with how many parameters, or we can pass in an entire collection. And we'll have more to say about that later after we've talked about interfaces. Or we can pass in a number to say what we want to start with. So maybe we know, I said a moment ago, arraylist starts ready to hold 16 elements. Maybe we know that we're gonna have 35 elements every time. And only 35 elements. So we don't have to let the computer wait until we get to that size, because it's gonna start with 16. When we get to 50% full, it's gonna double and go to 32. Well, I just said we had 35 elements, so when we get halfway full there, so when we get up to 16, it's gonna double and we'll have 60 space for 64 elements. But if we only have 35 elements, then almost half of them are empty. We're just wasting RAM. So we can pass in an integer with how big we want it to be. Add. So the method is called add. What do we want to add to the list? And E has to do with generics. We're going to see generics soon. The angle brackets when we create them. E and T are the two we see most often. In class, I probably use T most often. That's the way I learned Java. T for type. Also E, I guess E stands for element. E and T are the two most common ones we see for those. Notice the add method returns a Boolean. So we can put that in an if else structure to make sure our elements add to the list. Or we can just ignore that Boolean. True, if it's successfully added to the list, it returns true. If not, it is false. Add with the other one, add all, so we can add a whole bunch of things at once. We can clear it, we can empty the list. Clone it, a shallow copy, we'll talk about what the difference between a shallow and a deep copy soon. We can search for stuff, contains, here's for each. Let's do that. Let's use that somewhere. Whoops, I didn't mean to click that. Oh, well, maybe I did. I click for each, it just jumps way down the web page. We're way down at the bottom of the web page there, and there's the descriptions on these. So let's have that for each. We can do it both ways. I'll put one of them up here. Actually, I would need to do that over here. I would need to do that over. It doesn't work so well in the JSP page. Some type of syntax here, we won't actually do anything with it. So let me throw in a main. That way it doesn't show error messages. And I'll just copy like this list over. We got the list here. Just showing you the syntax on this. Then I can come down a little bit. And we saw that for each. So we have integers. Integer, I'll call it I in my in. So that'll work just like the earlier one. But yeah, do stuff. We have indexes, so we could use that for I as index. It's not size, I should protect that out. Or int I equals 0, I is less than my int dot size here, which if you try to type length, you'll quickly notice it's not a predictive text list. So dot size for our list, I plus plus. And then we would do my int dot get index I. I guess I should put S out on that. Print out. That. So along with add and remove, we also have get to retrieve a particular index. We wouldn't need that here because on a for each loop, we're just grabbing them one at a time. So we could say my S out I is exactly the same thing as the get I. Those are the same. Or I'm gonna hit the import. Notice my cursor was way down here. I hit Control Shift I and made those red lines way up above go away. Hopefully all this stuff is somewhat, it seems almost intuitive. because we've seen a little bit now, probably a little bit confusing. And built into each one of these, we also have a for each loop. These need a little bit of something else. We have to make a lambda function. Everybody see lambdas in Python at some point. Lambda goes all the way back to 1959 in list. Basically, it means wait. Have you all ever had that exact thing where you have a method, but you don't want to run the method, it won't run until you type the parentheses. Has everybody seen something like that? Like if you just say, print out and then the method name by itself, the console will just tell you have a function. But if you print out the method and then parentheses, it'll print out the result of that function. When the parentheses are there, we need to wait. So that's when it runs the function. A lambda essentially just waits. So the syntax for that in Java is we give it some sort of name. I'll call it I here. I'll call it I again because we have integers. And then the thing that most people would type to and call an arrow, a generic arrow dash thing, it's actually supposed to look like a lambda. The Greek letter lambda, well, uppercase looks like this, which that's the syntax I would have gone with, like a / backslash. But a lowercase lambda looks like this. So somebody thought that dash angle bracket kind of looked like the lowercase lambda. So that's why we use that symbol here. Then we put in some curly braces, and then we can do stuff in there. So notice how the curly braces go inside of the parentheses for the method call, and then here we can print out. So that was just to do the syntax. We jump away from the web page for a second. But we have 3 different ways to do the loops. And we should put those in order. I'm going to hit cut here and move this one up here. There we go. Now they are increasing efficiency. So this is the worst way to do a for loop. This is a little bit better. And when we have a list, this is the best way to do a list. As far as resource usage, optimizing RAM and CPU usage, our various cores, which we won't see that full. We won't see the various core, how to use multiple cores to modulate, multi-threading. All of that is optimized the most when we get down to this strip, that third one. So increasing efficiency there. For general in this class, just use whichever syntax you like. Whichever one of those looks the best, you think it looks the best, that would be fine for class. Maybe try to change it up a little bit and use all 3 at different times. But again, we have that lots of options thing. And kind of like we did here, we did a couple things in a row with the main method. You might want to get some practice with JSP pages because that will be on your final project. So any of the homework assignments, if you want to, you can put them in the JSP page. The Java code is exactly the same. What changes is whether we put it in a main method or in one of these tags. But if you want to do some of your homework in that way and start getting practice now with integrating that, making things look better, that is fine. I would highly recommend getting some practice with it because it is part of your final project. Let me look at Java docs real quick. We haven't really seen that. I'm gonna go back to the earlier project. Y'all will get some practice with that. We're just quickly kind of going over stuff. So I'm gonna open this Java one here. I'm gonna delete that extra class that we put in there. That was something that didn't work. So a multi-line comment, we do slash and asterisk, and we come down a couple lines, do asterisk slash. It'll fill in everything, and everything in between is a comment. But in Java, we have a special kind of comment. If we do slash and then 2 asterisks, it gives us the Java.comment. So like notice it says author, so who wrote this class? And then it automatically left a blank here, so it's waiting for something to put in this line. Like a summary of what goes here, so, this was our class example introducing arrays. Then we have the main method. This will be enough just for a quick version. Again, I'll do a multi-line comment with an extra asterisk at the beginning. And notice this time it added that annotation at param args, and we can see right here what args are. That's the parameter we pass in there. Inline arguments passed in when we start the program. Some sort of description of that, and then we could give it, again, we have a description here. I'll jump ahead. This is to generate a web page, so it knows what HTML is. So if we want to put put in a paragraph tag, this is the main method. In the paragraph tag, and then we can add another paragraph tag. A main method has to be, maybe add a bold tag, has, and then in that bold tag to be in every Java program. So notice it's to generate websites. I haven't clicked the button yet, but we've already looked at HTML. When we make our Java doc website, we can add HTML in there and make our documentation look a little bit nicer. But really, we just need some sort of description like this, and then whatever parameters we have, whatever annotations we have. So like at the author of this class, at the parameters we pass in. Before long, we'll have at return. That's the ones we have most often. At param, what goes into the method, and at return, what does it send back? When we just looked at that Java doc, that's what we keep seeing everywhere, right? What's it return? Oh, what are the parameters and what's it return? This one returns a void, so don't have to worry about that. But on the next one, we have specify, what's it return, where's it? Overall return, we have things like that. So I scroll way up to the top, actually. I was hit keyboard shortcut to get to the top so we can see the way the page looks here. If I come over here and save that, I run the Maven project, if I right click, you see there's a button for generate Java doc. So now that those comments are on there, I just click that and give it a minute. The Maven project actually slows everything down. It's quicker in an Ant project, but it'll, it shouldn't take too long. Did I finish? Okay. Taking longer than I expected. Okay, there we go. Eventually I get down to build success. So if we go over to File Explorer and here in NetBeans projects, that Maven project 1, target is our build stuff. So we go to the target, you'll see Java doc, and under site, you'll see a bunch of HTML pages. So in target, the project Maven project, the target, you'll see site. Most of the semester we'll be doing class examples with the Ant package management, and that puts it in a folder dist for distribution. But the same sort of stuff. The folder where our build things goes, the folder API docs, and a whole bunch of web pages, a bunch of HTML, SVG for diagrams. So it apparently put some diagrams in there for us, a whole bunch of JavaScript, but I see index, so I'm gonna go ahead and open the index one here. And there we can see our, the name of the class, what was in it. If I click on that. So there's that description of the project that was written up here. See, that sentence just ended up there, the overall description of the project, the author name. Instructors will get to, we don't have any, but we'll talk about one. There's one there before long. Oh, there's the main method we created. So the main method, get that description or click on that and it comes way down here. This is kind of nice. Notice it extends object. That's the like parent class. Everything in Java is object oriented, so it all comes down from that. That's the starting point. But if I click on this, look where we go. I'm back to the official page on Oracle. So it automatically links anything that we use from the official documentation. It automatically links back to the official documentation for us. Java docs are awesome. Just from a few comments, we generate that website. So I will be asking for those in your stuff before long. It's definitely a requirement by the final project, but before then, I'm going to start requesting that you put Java docs in there to start getting practice with it. But you can see it's fairly easy. We just put some short comments there and then right click on the project and right click on the project. Whoops. Right click on the project and highlight the project, then right click and generate Java doc to get that website of documentation. Because nobody wants to read the comments or dig through source code and read those. We want to make it look nice like old page and stuff. Same reason we're using those JSP pages. Eventually, well, this evening was for output, but eventually we'll be using those for input because they look a lot better than working in a terminal. So again, a lot of stuff still in our syntax class. Thursday, we'll finish up our syntax class, so we should be finished with the basic syntax, which you can get up to methods before the break. So then we'll get into object-oriented stuff and just kind of fill the rest of the time we have on Thursday. As far as this evening, that was kind of what I wanted to put on there. A brief introduction to that stuff, because you're going to want to go type that stuff. This is an active subject. You learn by doing. You're only going to learn so much by listening to me talk about writing code. You learn to write code by writing code. So some brief examples. We should finish our basic syntax and then get started into the interesting stuff before the break on Thursday. But by the end of the night Thursday, we will be getting into the interesting stuff in Java now that we've seen all the syntax. So one more thing to go there. Any questions before we wrap up? Okay, I assume 5 seconds of silence means there's no questions. If you have any, let me know. I'm always happy to help. Otherwise, I'll see you on Thursday and we'll look at methods and then get started into object-oriented stuff. And more interesting things than just covering syntax on logic that you already know. Introducing new bits of logic and stuff. I'll see you then.